So now that we've covered all of our transformations for our graphs, we're going to take it a step further. We're going to look at some applications that we can do with our sine and cosine graph. We're going to focus on the sine application, but just know that the cosine applications would follow very similarly. So basically what our application problems are going to be like is we're going to be given a situation or given a graph or some data, and we're going to want to create an equation for that data or for that graph. So basically now that we know kind of all of these different terms that we've learned, amplitude, period, shifts, we're going to take that information and now work our way backwards. Now if we think about what our sine and cosine graph look like, they look kind of like a wave. And so those are most of the applications that we're looking at. We're looking at like light waves, we can look at normal water waves, we can look at sound waves, and then one other type of application is anything that's going to repeat itself kind of on the same pattern. So another one would be your temperatures, because think about that, like your temperatures are going to repeat every year and they're going to be around the same kind of area or the same kind of temperatures at a given time. So together we're going to go over a model of water waves, and then on your own you're going to do kind of a small lab that's going to be over temperatures. But realize that this process is going to be the same because your data will look very similar. It's just that the application itself is a little bit different. So our problem says the table shows the depths in feet of the water at the end of the dock every 2 hours from midnight to noon, where t = 0 corresponds to midnight. Use a trigonometric function to model the data. And this is basically what I was talking about, is a model. It's kind of another word for an equation. So I want to figure out what equation can I use to represent this data. And like I said, we're going to focus on sine, but you could also use cosine. It's not going to be a ton different, but just for consistency's sake, we're going to focus on sine. So realize now that we've gone over all of our trig functions, all of the transformations for those functions, we know that our general equation is a times sine of bx minus c plus d.
Nathan Myers, please come to the front office. Nathan Myers, please come to the front office.
So with that, we basically need to find A, B, C, and D to fill in. And we're going to get that from the data that they've given us. So notice that we have time, which is our t value, or our independent variable. And then we have depth, which is our y value, which is going to be our dependent variable. So we're just going to kind of work our way through each of those variables. So let's look at our first one. So our first one is going to be our A value. Now remember that A stands for amplitude. And we said that the definition of our amplitude is half the distance from our max to our min. Well, if we think about what half the distance from our max to our min is algebraically, well, half, we can say, okay, that's 1/2. And if we're taking a half of something, that's going to be multiplication. And then we're taking half the distance from the max to the min. Well, distance is going to be given to us by subtracting. We know that if I want to find how much space have I covered, if I start at 5 and get to 10 feet, I would subtract them. And the difference between them is going to be the distance that you traveled. So we're going to have our max. And notice that this is our maximum y value minus our minimum y value. Because remember, amplitude is basically talking about how tall or how far up and down we go, which is why we're talking about y values here. So then what we need to decide for our data is which one's our max, which one's our min, and then just plug it into our formula. So looking at our data, hopefully we notice that 11.3 is going to be our maximum, and 0.1 is going to be our minimum. So plugging into this equation for this specific problem, we get 1/2 times our maximum value, which is 11.3, minus our minimum value, which is 0.1. So we have 1/2 times what we would get 11.2, and then 11.2 times 1/2 is going to give us 5.6. So 1 down, 3 to go. Kind of on a roll here. Now, the big thing to kind of think about next, we could go in order and we could find B next. The only problem with that is your inside stuff is going to be not like harder, but it does take a few more steps. Whereas our D value, the number on the outside, actually is pretty similar to our A value. So we're going to go ahead and skip a little bit and go and find that value next. So for my D value, now, let's think about this graphically. If we're looking at a graph or a sine or cosine graph, and we've shifted it, so our D value, remember, shifts our graph up and down. So we've shifted it to some spot up above our x-axis. Well, we know, and when we learned about it, we said, okay, well, our x-axis, we can kind of think about it when I shift it, that is like our new x-axis. But notice that because pretending that that's in the middle like it's supposed to be, remember that whenever we shift that our minimum and maximum still have to be a units away from our new x-axis. So your D value, that imaginary line that we've created, has to be exactly in between your minimum and your maximum. So we need to basically find the midpoint, the mid value, or the average between those two things. Now do realize that this is a little bit different than our A value, because for our A value, it was the distance between the two things, so it was the range, whereas this is the average, or the middle of our two things. And so instead of subtracting, remember hopefully that to find an average, I'm still taking 1/2, but it's going to be 1/2 my maximum y value plus my minimum y value. So for us, still using those same two numbers that we used above, we have 1/2 times 11.3 plus 0.1, which gives us 1/2 times 11.4. So we get 5.7. All right, we are halfway there. We have 2 of our variables. So now we need to find our next 2 variables. All right, so our next value that we're going to look for is our B value. Now remember that our B value is kind of dependent upon our period. So we're going to look for our period of our graph. And again, let's go back to thinking about what our general sine graph looks like. So remember, for our sine graph, we start and we end at a 0. And it takes one full cycle, or one period, to go from a 0 to another 0. So let's look at, again, this graph that we had up here. So if I was just looking at our basic sine graph, it starts and ends at a 0. And in between those two things, for our normal graph, would be 2 pi. And that's how often it's going to repeat itself. But notice that if we were to continue our graph, because it's a periodic function, that if I were to look at any two of the same type of values, it also has to be 2 pi in between those. So if I have a maximum to a maximum, that would also have to be 2 pi. Or a minimum to a minimum would be 2 pi. Well, notice that on the data that they give us, okay, we have a maximum value and a minimum value. And because we've shifted everything up, we don't really have a 0 value, so it makes it a little bit harder. Because, our D value, remember, is our new x-axis, we're looking at 5.7, and that would be where our, kind of zeros, you can think about them, would hit. But notice that on our y values, we don't have any 5.7s. So we don't know how far we've had to shift over or anything like that to be able to find our B value. But what we can do instead is we can think about, okay, I have a maximum and I have a minimum. I know that to go from one maximum to the other maximum on my normal graph is 2 pi. Or it's going to be the period of the graph if we've at all changed it. Well, we also know that, hopefully we can tell, that halfway in between my two maximums is my minimum, which means that half of my period, which would be pi, is going to be the distance that would be between our max to our min. So the distance between a maximum to a minimum would just be pi, or half of the period. And so we can use that same logic here. So we know that half of the period has to equal the distance between our maximum and our minimum values. But we want to look at the corresponding x value. Because notice when we're talking about the period now, we're talking about horizontally. So we don't want to use our y values, we want to use our x values. And again, because we're talking about the distance between two things, we want to subtract. Now, because we're subtracting, we don't always know if the maximum is going to have a bigger t value or if the minimum is going to have a bigger x value. So what we're going to do is to kind of counterbalance that, we're just going to take the absolute value. So we're going to look at our maximum, but this time we're using the x value. And we're going to subtract the minimum, but again, this time using the x value. Because again, that's going to give us that distance between our max and our min, and we know that that distance has to be half the total period. So again, we have half of our period, we have the absolute value. So if we look at our maximum value is 11.3. the x value that's associated with that is 4. Then we have our minimum value, which is 0.1, and the value that's associated with that is 10. And then we're just going to work it out. So we have 1/2 p equals so 4 minus 10 gives us -6. The absolute value of -6 is just 6, which tells us that our p-value has to equal 12, because we would have to multiply by our 1/2. Now, that's my p-value, that's my period value. That doesn't give us our b-value. Now, remember that our b and our p are two different things. I cannot, please, do not just plug in 12 for b. Because remember, we get our period from the b-value, but they are not the same thing. Remember when we talked about it and we found it, they have an inverse relationship with one another. So we know that if we wanted to find our b-value, so we know that the period of a graph equals 2 pi divided by b, which means that if I were to multiply by b to both sides and then divide by p, we know that our b value is going to equal 2 pi divided by the period. So in this case, for our specific problem, our b value is going to equal 2 pi divided by 12. We can reduce that to be pi over 6. So 3 down, 1 more variable to go. Now, the last value, our c value, is usually what causes people the most trouble. That's not to say that it's super hard to find, but it is a little bit difficult to kind of think through our steps. So I want us to listen to kind of what I'm describing here, okay, and kind of walk with me through this thought process. So remember, our c value is how far, either left or right, that we've shifted. But remember that it's not just our c value that we've shifted left or right. It also depends upon our b value. Because remember, in order to find how far we've shifted over, we have to take our c value and divide by b. So when we're looking at data, it can be a little bit difficult to try and figure out, okay, how is it shifted when I've already applied all of these other values? So we've moved everything up, our period is different, our a value is different, so it can be a little bit hard to figure out what that's going to look like. So what we want to do is try and relate kind of our parent graph, okay, to what we're trying to get. So remember that, like, when we're trying to find our starting point, we set the inside of our equation equal to 0, because we're wanting to find where the new starting spot would happen. So we're setting our new equation equal to the old spot that it happens. And we're going to do a similar thing with this. But notice that on our data, we don't have a 0. Remember that kind of our imaginary 0 line would be at 5.7. And I don't have any y values that are at 5.7. So I can't use that 0 value, okay? But we do have a maximum and a minimum. So again, we're trying to set the inside of bx minus c equal to the old spot that something happened, okay? So we can't use a 0, but we can use a maximum or a minimum. So what we're going to do now instead is we're going to think back to our original graph. Okay? If I was looking at that graph and we were wanting to use a maximum, we don't want to use 0 because our maximums don't happen at 0. Notice that our maximum happens at, hopefully we recall, it's at 1, and we know that sine is 1 at pi over 2. So we know that we have a maximum value at pi over 2. We're wanting to use our new maximum value. So again, what we have to do, we're going to set Ex minus C equal to where our old maximum value happened, so that was pi over 2. And then we're going to plug in where our new maximum x value is. So notice that our pi over 2 is the old max. X value. And we want to plug in the new max x value. Because then that's going to tell us, okay, if I plug in my new maximum x value, we've already found our b value, so we can plug that in. Well, then the only variable we have left is c. So then we can solve for c and look, okay, how far did I have to move my new x value to get to that old x value? And so then that tells me what that c value is. So plugging in, like I said, we know that our b value is pi over 6. We're going to multiply that by the new location of my maximum, or my x value of my maximum, which is 4. Well, we don't know what c is, so we have minus c. And then we're going to set that equal to pi over 2. And then we're just going to solve. Okay, well, I know that 2 goes into both 6 and 4. So that gives us 2/3. And then we would need to add c to both sides and subtract pi over 2. So we end up with 2 pi over 3 minus pi over 2, which equals c. We would need to find a common denominator, which is going to be 6. So you would have
Jessica Holman, can you please come to the main office? Jessica Holman.
we would have to multiply our first one by 2. So we would get 4 pi over 6 minus, we have to multiply our second one by 3. So we would get 3 pi over 6. So 4 pi over 6 minus 3 pi over 6 gives us a c value of pi over 6. So then now, what we want to do is basically plug all of that in to find that first equation. We did all of that work now to be able to plug back in. So our answer to part A is going to be y equals, we said our a value is 5.6. Our b value we just said was going to be pi over 6. So we have pi over 6, and then we want to leave our x there. Sorry, I forgot my function. Sine. So 5.6 times sine of pi over 6. And then we want to leave our x value there because we still need a function. We still need something to plug into. Then we want our c value, which we found was also pi over 6. So minus pi over 6. And then plus our d value, which we found to be 5.7. So then it asks us for the depths at two specific values, 9 a.m. and 3 p.m. Those are our times. And so we can now plug those in for our x value, because remember our x is like our t. So we would want to take that 9 and plug it in. So we would have y equals 5.6 times sine of pi over 6 times 9 minus pi over 6 plus 5.7. We would take that and plug it all into our calculator. You do want to make sure that you're in radians. And if you're going to plug it in all together, you need to be really careful about your parentheses. And that you're putting parentheses around all of the stuff that's inside of your sign. And that you're either using the fraction operation, or if you're using your division bar, you need to make sure you do like parentheses pi divided by 6 if you're going to do it that way. So if you plug it all in to your handy dandy calculator, you should get 0.85 feet for your first answer. And then for the second one, be careful. You don't want to plug in 3, because notice that 3 would represent 3 a.m. I don't want 3 a.m. I want 3 p.m. So we would need to plug in 12 plus 3, because we've gone 12 hours plus an additional 3 hours. So you would need to plug in 15. If we plug in 15 into our handy dandy calculator, into that spot again, making sure that you put your parentheses and such in the right spot, you should get 10.55 feet. Which notice if we look at our depths, 9 would it be in between 8 and 10? 0.85 is in between 3.8 and 0.1, so we're still coming down. So it looks like it would match our data. 3 p.m. Is going to kind of be back again, since it's repeating itself, to be between 2 and 4, and we get 10.55, which again is between 8.7 and 11.3. So it looks like it's fitting into that pattern. That's going to be a good way to kind of check yourself. Okay, do the answers that I get make sense in terms of my other data points? And so those would be your answers. And then for right now, we're going to skip part C, and we'll do that a little bit later. But the big thing is going to be you're going to need these A, D, B, and C formulas. Because remember, like I said, that process is going to be the same no matter what your data is. So you're really going to need to make sure that you know those and can use those for any type of data, which will include the temperature data that you'll be looking at next.